What is that hissing? Okay, that's part of the demo. Okay. Sideband practice. Welcome. Welcome to UARC. My name's Tom Schaefer, NY4I, and I'm the president of the club for only another 7 months. No, just kidding. Oh, wait a minute. I forgot something. Oh, this is terrible. Recall. You ready, Fred? This is the new ARRL repeater guide. We have 100 of them, minus a few. So if anyone wants one of the new ones, you can see Fred at the back table. All new, improved. Correct, 100% accurate. Well, each individual that's accurate. Is that all right, Fred? All right. I think they're $8. They're $8? $8.50 with that tax stuff. You have change. Well, that's good. All right, what we'd like to do is, well, what I'd like to do, you can do it if you want, you don't have to do it, is let's start, well, we won't start over here. Let's start over here and introduce yourself and tell us your call, and just so everybody... I see him right here. Okay, thank you. It really helps. What was I going to say? Oh, how many people who are Unix or programmers know what VI is? The VI guy over there, the reason I had to tell this, the reason I call him the VI guy is because he came to a code test and decided to type the code test into the computer using VI. I mean, he should pass just for, you know, I mean, I figured he would just you know, for effort. Anyway, that's for other people, that means absolutely nothing. Okay. What was next? Oh, yes. See the banner? We all need to thank Maureen and Chuck for taking care of getting our banner. We used it at the Scoutorama, which we were at this past weekend, which we all went out in the field, took the club generator and the tower, and we set up all kinds of stations and had a blast. I'd like to start a round of applause for Eugene, K7HFV, who organized that whole thing. Thank you, Eugene. Okay, and yes, sir. Yeah, they had one at the college down there. All right. All right, good. Okay, good. We had a lot of fun up there too. It was a good exercise. A lot of people wanted to talk to us. They were excited what we were doing. All right. Am I forgetting anything? Oh yes, Gordon. I need 2 more minutes. Joel, come on up here. Oh wait, I need 5 more minutes. Joel, Gordon's telling me to stall here. Joel, as some of you may know, is our field day chairman. For those who don't know what field day is, he's going to tell you. Joel.
It's a thing they do on a Friday, Saturday. Basically what it is, from reading literature, talking to other fellow hams, is a day that we go out, that we do contesting, we set up equipment to simulate and demonstrate emergency preparedness and setting up equipment and make sure that it can operate. Experimenting, I understand they experimented with an antenna last year and had some difficulties. So I was letting that one go easy. I'm new at this. I've been a ham a little over a year. A friend of mine, Bill Oberg, AA7XS, is a neighbor of mine. He encouraged me to do this. I'm glad I did it. I would encourage the new hams and the ladies that are sitting here that come in and participate with us. I don't have the slightest idea what's going on, but with the support of the other hams, I feel confident, and a lot of people are stepping forward to help out in this effort. and I would encourage the new hams in order to come up with us. This is a 24-hour around-the-clock effort to try to do the contesting, getting out. We'll have CW stations, we'll have phone stations, satellite. We're going to have solar panels so we can get credit. Certain things you do, you get X amount of points for. So we want to try to operate around the clock. And there are some dedicated people that do want to stay up all night and do this. They're a little crazy, but I'll probably be one of them this year with them so I can learn. But it was good. I participated with Eugene in Scout-O-Rama, and I learned a lot there on setting up the equipment. There's a lot for the ladies that are coming in or thinking about it. There's some neat ladies that I've heard, Venus and Maureen. I forgot your name. Carla, that are really good, that wants to try to encourage the ladies to participate. So there's a lot of neat information. The people here are willing to give you a hand and help out and come out with us and participate. It's going to be a lot of fun, and there's going to be good food. It's going to be the end of June, 27th and 28th. Yeah. It's going to be at Spanish Lakes, Payson Lakes above Spanish Fork. And so we'll be up there. Next month, we'll be going into more detail, and Tom's put me on the spot, said I have a longer talk next time. So I got to be better prepared. No.
Oh, see, this was all part of a big plan. Okay. We ready? All right. Oh, well, I figured you'd do that during your thing. You want to do that during your thing, or is it not apply? Okay, I'll do that. I've been requested to say this. I know we've had a problem on at least one of our repeaters. I don't know if that problem's gotten to 7.6 yet. I know we've had a problem on one with somebody broadcasting. I've also heard some fairly foul language on it at times. I can't stress enough, no matter what is said, no matter how stupid you think it is, don't say a word. Don't acknowledge it in any way, shape, or form. Don't say to the person you're talking to, oh, I hope they get that person, I hope they find them, I hope they do this, I hope they do that. Because even though you're not directly talking to that person, you're acknowledging that person, which is exactly what they want. I know it's the hardest thing in the world, but one of the best ways to handle it is to just absolutely ignore them, like they weren't even there. Yes, sir.
Just wondering, I work at the airport authority and I've got a lot of equipment, and I was thinking I've been listening on 6.2 and sending a lot of information onto a zip drive. I'm hoping to be able to fingerprint that radio for you if you want it.
That might be useful. Yeah, I think that. Yeah, we can, as we're talking about it, of course. We can talk all we want about it, but yeah, that might be useful. I'll tell you who to talk to. See me after the meeting. We'll talk about it. Okay, no matter what they say, no matter what they do, at all, anything, don't acknowledge them in any way, shape, or form. Okay, just pretend you didn't even hear it. And if it gets really bad, do what I did, which was last Saturday or 2 Saturdays ago. I just turned my radio off because I didn't want to listen to it. Yes, you can go now. Go ahead, Steve. Yeah, that would help. That would help in finding whoever it is. If you want to listen to the reverse and just keep track of where you are and relatively how strong you saw it on your radio, that might be helpful information to someone. We can give you information. Gordon will tell you who to give that information to, because you probably don't want to give that information on the air either. That person jamming was S5 at from this location. That wouldn't be good either, because that's still acknowledging it. Okay. All right. I think the banner's gone. Letters out. Yeah, just put letters out. I think we're done. So. Actually, I need to introduce Linda, who's one of our program chairpersons, so she will introduce our speaker. Linda, it's the wireless.
Oh, okay. Well, we're very happy tonight to have Gordon, K7HFV, who is going to be talking to us about FM, and it should be very interesting. And Gordon's been in amateur radio for a long time, and he knows all the knowledgeable things, and yeah, I'm really looking forward to hearing this tonight. So we'll turn the time over to Gordon. And one thing I'd like to say, if anybody wants to give me a call at work and tell me where they hear this guy on the reverse, I can write it down. But do not call me on the radio and say, Linda, he was this. If you want to call me, just call me at 468-2750, and I will write down what you tell me, and then I can report it at our meeting or give it to whoever needs to have it. Thank you. Now I'll turn it over to Gordon.
See, I guess you talk into this thing and something happens. Good. If no one can hear, that'll probably be better. Have you ever heard somebody on the air that just had a really rotten signal, in fact so bad that you just got occasional syllables here and there, and you kept telling him, I'm sorry, we can't copy anything you're saying, and he just keeps trying and trying, and you get just a few little syllables here and there, enough to get things like low power, handheld, underpass, and I think rubber duck, that's another one of the things that pops up. Now, I think I've figured out what's going on in that case. He's trying to tell you that he has a really good excuse for having a lousy signal. And if you could just understand how good his excuse is, then you'd start copying him. So I think that's the rationale for this extreme persistence to get the excuse across. And I'm going to try the same tack here tonight. When I first volunteered to do this program several months ago, it was because I was trying to find the field day slideshow, and I came across this set of slides I'd put together about 10 years ago for a presentation at the Davis Club meeting. Thought, wow, I could put something together with hardly any effort. And well, as Murphy would have it, this week when I went to go find those slides, they weren't any place to be found. I don't know how that could happen, because I keep my house in such immaculate condition that a lot of people have commented on it. I guess those weren't the exact words. It was something like, I've never seen anything like this before. But anyway, I hope between the whiteboard and a good imagination we can present some of what would have been in those slides. Now, I assume that you've all had at least first-year calculus, because what I'd like to do tonight is run through the derivation of the Bessel functions for FM sidebands, and also show you some of the circuitry. Well, no, not really. Actually, I'm hoping to direct this at the beginner level. So those of you that wanted a really detailed professional presentation, there's probably still time to get home and catch the game. But I think FM has become our most popular mode in ham radio. We have the no-code license and a lot of new people getting in. And the mode that most people get on is the FM mode. But FM has a lot of things that behave differently than other modes. In fact, they're really non-intuitive. And so I'm hoping we can demonstrate some of those peculiarities and maybe help you understand what you're hearing when various things go on the radio. I guess to start talking about FM, hopefully everyone knows that means frequency modulation. Maybe we have to start by talking about what modulation is. Now, hopefully everybody in the novice test learned that we have audio frequencies and radio frequencies, right? As I talk into this mic, it's producing a voltage somewhere inside there that's varying at audio frequencies, somewhere in the 30 hertz to probably no more than about 3,000 hertz. Our little handhelds on 2 meters put out an entirely different frequency on the coax jack. It's up there in the 150 million hertz area. And as you might imagine, signals that far apart have totally different characteristics. The nice thing about the 2 meter signal is we can pump it into a little antenna and hear it all the way across town. The disadvantage is that when I say hear it, I don't know exactly what I mean by that, because it's too high to hear and it's too low to see. So it's nice to know it's there, but what can we do with it? Well, the trick is that we want to take the audio information, voice, music, what have you, hopefully not music in the amateur service though, and we'd like to use this high frequency, this radio frequency, to kind of carry it to another place. So that's why we have a signal called a carrier. In fact, Dennis has a nice little scope up here. It's capable of seeing frequencies up to our 420 band even. Let's see, Dennis and/or Ron, do you want to see if you can make a nice sine wave appear there? One of the other things we can mention is that this scope is for sale, and Dennis would be very happy to talk to you afterwards if you have any interest in procuring this. This is a really nice Tektronix instrument, and we talk about a single frequency signal or a sine wave, and hopefully we have one there. This is the kind of waveform that we're talking about when we talk about that. I'll try to draw some on the board, but they won't look nearly as pretty as the real one on the scope here. So right, this is just an antenna connected to the scope, so it'll hear anything that's floating around the room, including our wireless mic here and anybody who happens to key up. So if you ever wanted to know what your carrier looks like, what the horizontal axis there is time, and the vertical axis is the voltage that's coming in on the antenna. So it'll look at pretty low voltages as well as pretty high frequencies. Well, anyway, we've got this problem of how do we use this radio frequency signal to carry this audio frequency signal. And the way that occurred to the early pioneers was we can change some characteristic of the radio frequency signal to follow the audio frequency signal. And the way we did that in the olden days was amplitude modulation, in fact still do. What would be another word for amplitude? What does amplitude mean anyway? Anybody have a suggestion? Loudness? Yeah, a loudness, that's a possibility. With what was that? Height? The way we draw it in the diagrams is usually with height. Power, okay. Yeah, that's probably a good way to look at it. I hesitate a little bit to equate amplitude to power because we usually think of power being the square of amplitude, but it's true to say that if the amplitude goes up, the power goes up too. So maybe if we have this audio signal that maybe goes up and down, what we could do is we have a much faster changing RF signal, so maybe we could have high amplitude when the what was that? Oh, can't see a thing. Okay, thank you. We'll try a different color. Okay, I guess we were using a radio frequency color from the pen here, so you couldn't see it. Anyway, suppose we had an audio signal that looked like this. Maybe what we want to do is change our RF signal so it does this kind of a trick. Maybe when it's at an intermediate voltage like that, we'd have an intermediate amplitude, and then as the audio signal gets higher, we'll let the RF amplitude get higher, and Then as it comes back down, it'll do this, and finally might go right to 0, where the audio signal's at its lowest point. So this little pattern's what we call amplitude modulation. We change the power or the signal strength in accordance with whatever audio signal we're trying to transmit. And this is the mode that kept us going for a lot of years. Robert? Right, they use that in the AM band. In fact, that's why it's called AM broadcast. So this is the mode back in the teens and 20s. This was the only way of sending audio that there was. And by the 20s, we had a lot of radio stations on in the country. In fact, we even had one out here in the Indian-ridden West. KSL came on in 1922. But there weren't a lot of stations on. There certainly weren't 30 or 50 in the Salt Lake market like there are now. And if you were in Provo or Ogden or Richfield, you were probably out of luck trying to find anything local. So a lot of people were trying to hear some very distant signals. And one of the things that happens when you do that is there's a lot of noise. Well, you could hear the graybeards during those periods when somebody said, boy, it'd sure be nice if they could figure out a way to get rid of the noise, saying, well, nope, there's no way to get rid of the noise. It's just one of the things we got to live with that's out there in the atmosphere, and if you're going to receive radio waves, you're going to receive whatever noise goes along with them. Well, then somebody devised FM that was in fact a way to get rid of the noise. And the guy that gave that to us was Major Edwin Armstrong. Let me ask, how many here have ever heard of Edwin Armstrong? Quite a few. That's good. I think a lot of people don't know about that man and how much he contributed, but could probably make a good argument for Armstrong having contributed more to the development of radio than any one person. Back in the early days when they were first perfecting receivers, there was a whole series of improvements that things went through. There was a fellow named Branley that invented the first coherer, which was a detector type device. But he didn't have in mind using it for radio. He was trying to do experiments with electricity and frogs, I believe. So another fellow named Lodge came along and figured out how to use it for radio and improved it a bit. And another fellow from India came along and improved it a little better. And Marconi came along and added his improvements. And before long, we'd improved things from going across the room to going across the Atlantic. Well, there was another series of improvements just like that after the vacuum tube came along, because suddenly we could make receivers that were thousands of times more sensitive than anything we'd had before the tube. And that went through its whole series of improvements too. We had straight diode detectors, and then we had tuned radio frequency receivers, and then we had regenerative detectors, super regenerative detectors, finally the super heterodyne, and some of the things that sprung from that, like the autodyne. But the difference was this whole series of receivers was all invented by the same guy. Edwin Armstrong invented the regenerator, the super regenerator, the super het, and I guess that's where he stopped. And I guess that's where we all stopped, because that's still the receiver design that we use in about 99% of the cases. So he made some remarkable contributions to radio. He developed FM in the period between the late 1920s and the early 1930s because of some fighting going on between him and David Sarnoff of RCA. FM broadcast stations didn't really hit the air until much later. But it's interesting that FM had been developed that early in the game. So what we do with FM, I always thought when I was young that if in amplitude modulation we use our tuning knob on the radio to select the frequency, and we send the audio by changing the amplitude, then in frequency modulation it must be the other way around. Since we're using the frequency to carry the audio, we must use the tuning knob to pick out an amplitude to decide on the right station, but I found out that wasn't the way it worked. What happens is we still have a center frequency, but we let the frequency change with the audio. So in our audio signal here, we'd start out here perhaps at our center frequency, and then as the audio signal went up, we'd just move the carrier up to a higher frequency. Those little periods between the cycles that we saw in the scope would get a little bit shorter. And then when it goes back down, we bring the frequency back down. And when it goes past the center point, we start moving it below where our center frequency was. So there's an issue of just how far we should move the frequency. Our standard on the amateur bands these days is that we start with a center frequency and move it up 5 kilohertz and down 5 kilohertz from the starting point. And so we say that our deviation is 5 kilohertz. The amount that we move it, both positive and negative from the starting point, is 5 kilohertz. So let's say that our center frequency is 146.62. What frequencies are we going to swing between? Let's see, I heard a 5.7. We'll find out who passed that part on the novice test about kilohertz and megahertz. Actually, we'll go from 146.695 to 146.625, because that last digit is really kilohertz. So let me write that down just for reference, if I can only get the top off the pen. This point would be 146.625, and then down at this negative point, that would be 146.695. Whoops, 1.5. I'm glad somebody's watching this. Back in the days when most of the 2-meter activity was on AM, there were some people that gave a program like this that really knew what they were doing. Phil Bullock and Craig Jensen and some people that worked in the industry and really knew their way around. I was hoping to find some of those people that would help tonight, but all the people I've talked to said it would be a lot more fun to just sit back in the audience and complain about the mistakes. So I appreciate the corrections. You're quite helpful. I do hear some things on the air, though, people telling people that their audio is bad when in fact there's nothing wrong with their audio, and telling people they're weak when in fact they aren't weak. That I thought maybe there was a need for this kind of a program to see how some of this works. But this is the basic idea. As the audio changes, we move the frequency up and down, and in the receiver we have something that turns the frequency back into a voltage, and we recreate the audio. Except that isn't really how we do it. There is this other form of modulation called phase modulation that's a close cousin to FM, but not quite the same. Let's suppose we had an RF carrier here. Imagine that this really looks more like the pattern on Dennis's scope. If we drew another signal that was a little out of phase with that, it would have peaks that were coming just, say, a little later or a little earlier. I'll draw it here as if it's later. Well, let's say that somewhere between here and here we decided to change the phase. So that means the signal would now come up and do this kind of a thing. It's been phase shifted. Well, notice that the distance between this peak and this peak has gotten wider. That means that the time between cycles is now longer, at least for that one cycle, than it was before. So if the time it takes for one cycle is longer, that means the number of cycles per second is less. So in the process of changing the phase, we've also changed the frequency. We only change it momentarily. When we get looking at that peak and that peak, they're back to the original distance. So we only change the frequency momentarily when we change the phase, but it turns out you can't change the phase without changing the frequency, and you can't change the frequency without changing the phase. So these two kinds of modulation are quite closely related. And it turns out that since changing the phase faster changes the frequency more, how much FM we get from our PM is dependent on how fast the audio is changing. In other words, how high the audio frequency is. So the real difference between these two modes is how they behave when you put different audio frequencies in. And let's see, let me see if I can generate a little bit of PM here and receive it on a receiver. Let's see, something's supposed to be happening here, but let's see, these things always work beforehand. Oh, there we go. Maybe we, oh, I know what the problem is. Never mind. Set that back where it was. Operator error.
Thruster engine. The engine keeps Mir's solar panels properly oriented toward the sun. Cosmonauts Talgat Musabayev, RO3FT, and Nikolai Budarin, RV3F.
Okay, and I'm going to switch this generator from PM to FM. See if you can notice the difference in what the audio sounds like. This audio we're feeding through it is part of the ARRL audio service that's available each week. So we thought that would be appropriately hammy. It takes me about 75 keystrokes to make the switch to FM, so bear with me for a moment, but you will hear a change.
B completed 3 spacewalks during April to replace the thruster. While an April 16th tornado in downtown Nashville, Tennessee got most of the media attention that day, a second potent storm struck around the same time some 70 miles to the south in Lawrence County, Tennessee. Hams mustered to help in storm spotting, rescue and recovery, and damage assessment. Ron Mott, W4 says Skywarn spotters saw the tornado as it approached and tracked its path across the county. Bill Phillips.
Okay, did you notice anything? All the high frequencies went away. It got real muddy. That's what things would sound like if we actually transmitted FM to our receivers that are really built to listen to PM. So when we say we run FM on 2 meters, we're really lying a little bit because the standard is PM. It's also known as the EIA standard 6 dB per octave curve. Now, since the only thing you have to do to convert PM to FM or vice versa is make some changes in the audio, it's kind of handy. There's some transmitters that use phase modulators and some that use real FM modulators, and you can turn one into the other by just putting the right kind of a little audio network in front. And it's not a very complicated network. About 2 resistors and a capacitor is all it takes. Turns out on the receiving side, about the only detectors you'll find are real FM, so they have what we call de-emphasis, which changes the FM response curve to the PM response curve. So another way of saying we use PM is that we have pre-emphasis, which boosts the highs on the transmitter end, and we have de-emphasis, which takes the highs back down again on the receive end. And we do that because it really gives us a better signal-to-noise ratio. Most of the noise that we pick up on FM is in the high frequency area, and boosting the high end helps things out. Let's see, should I... Okay. Robert's going to make the noise go away here for the moment. Let's see, let me do another little demonstration here to show something that's different. Let's see, first of all, I need to get back to PM somehow. And
WD4KQV says the Skywarn net was activated on 2 meters the afternoon of April 16th, and ham weather spotters were among the first to report the tornado entering the county from the west. Skywarn net operates in cooperation with the...
okay, one thing we can do here is change the signal strength as if we were changing our power and antenna. And here's what it sounds like with a pretty weak signal, and I'll make it stronger. I'll make it stronger as if we multiplied the power by 100, and notice what happens.
Local Emergency Management Agency and net control operations reside at the Lawrence County Emergency Operations Center. Skywarn reports were relayed to the...
Okay, did his voice get any louder? No, didn't get louder at all. That's one of the, if you don't take anything else home tonight, remember this. The power level, the antenna, all those things that affect signal strength don't have anything to do with how loud the audio is on FM. Let's do that one more time.
National Weather Service and to local media
We'll make
outlets.
it weaker.
Mott says that at one point a tornado picked up a 1-ton truck and deposited it some 15 miles away. Phillips says the Skywarn activity helped speed up the official response to the...
The thing that does change is the amount of noise in the background changes. So we say that the received carrier quiets the noise, and about the only way you can tell how strong an FM signal is for listening for how much quieting there is. We finally get to the point where there really isn't any noise left to quiet. And what happens to the signal when we keep making it stronger after that?
Emergency. Because Skywarn is well known in the community, local fire departments and other county agencies monitor the Skywarn repeater, and we're...
Okay, did you hear that difference? Neither did I. Once you've reached full quieting, you can add more elements to your beam, you can put a 10-to-1 amplifier on, and no one's going to be able to tell the difference. So when somebody gets on the air and says, okay, I've got my handy-talkie on the old antenna, how's my signal? Well, it's full quieting. Okay, now tell me how much it improves when I go to my beam. He's very disappointed to find out that no one can tell any difference. Well, that's just because of the nature of FM. That full quieting point is hit with signals that really aren't all that strong. So the trick is, if you want to find out if something's improving the signal strength, start with the situation that's noisy and then switch to the beam, and then maybe you'll be able to tell that something happened. Okay, if the signal strength doesn't make any difference in how loud the audio coming out is, what does? Well, let's see. Maybe there's another knob we could turn here.
Service personnel into the stricken areas almost at once. Skywarn members began damage assessment once the tornado had cleared the county. During this phase, hams discovered at least...
Okay, now that adjustment clearly made a difference.
Help via ham radio.
The audio is not coming out nearly as loud as it used to. Why? Well, it's because we're not swinging this whole range anymore. We're doing something or other. We're probably putting it out a much smaller signal, kind of like that. Every so often you hear somebody on the air who is either talking from the back seat or he doesn't have a mic that's very well matched to his radio, And he has a great carrier into the repeater. It's quieting all the noise, but you can't understand a thing he's saying. And he keeps saying, oh, you can't copy. Well, I guess I'm going to have to get more power. I guess I'm going to have to get a beam. Well, if your problem is low audio, you can buy amplifiers till you run out of money and put up antennas until you run out of space, and it's not going to make a whit of difference. The only way to get the audio louder is to improve the audio before it hits your modulator. Remember, we start out with audio frequencies at the microphone, and there's a fairly limited number of stages in the radio that have something to do with audio. And what you probably need to do is take the screws out and turn up the little pot that has something to do with the audio. Well, it turns out there, in a good radio at least, is probably more than one pot. So I think ICOM was one of the first ones to delete this pot. But when Motorola started turning out radios for the communications market for FM, they discovered something interesting. Well, voice audio looks kind of strange. It'll have a lot of strange ups and downs, and then every so often a spike will go way up into the stratosphere. And when we talk about the deviation on a signal like that, we're talking about the very highest point it hits and the very lowest point it hits. And the problem is, if we set this up so that this peak and that peak just barely get to plus and minus 5 kilohertz deviation, most of the time we're down here in the 1 or 2 kilohertz area, so we don't really have much talk power. And the trick to get around that involves something called a clipper. It's a device that just clips the audio off at this point. It will not let it get above some level, no matter what the input signal wants to do. So if we could get rid of these peaks, then we could bring the whole level up and improve our ability to get through the noise, mainly. So inside your radio, somewhere, there are a couple of stages that do this trick. First of all, the audio will come in, and I'll represent a level control this way. Usually an arrow means something you can adjust. It then goes through a clipper. And then it comes out here, and there's another level control. And then it may go through a low-pass filter. And finally, it goes off to the modulator that actually does the work of changing the frequency. So what happens is, this clipper makes sure that we don't go past a certain deviation level. The low-pass filter gets rid of some of the distortion that the clipper generated because it shows up as harmonics, and if we can just filter out the harmonics, that'll make it sound better. And so these two controls are usually called mic gain and deviation. Now the deviation control is after the clipper, so whatever voltage the clipper clips at is going to stay the same. And if we set that up, if we set this up so that that clipping point generates plus and minus 5 kilohertz, then no matter what happens in the rest of the system, we'll never be able to go beyond that. And it's important not to go beyond that. Let me give another little demonstration here. What happens if we run the audio too high? We've seen what happens when it's too low.
The next day, hams helped complete the damage assessment, which eventually led to Lawrence County's being designated a federal disaster area based on damage reports. The storm was officially upgraded from an F4 to an F5 tornado. In northern Lawrence.
Anybody heard a signal like that on the air? You might be tempted to tell the guy that he doesn't have enough power. He's breaking up. In fact, we got lots of signal strength going in there. What's happening is, remember that the signal's swinging up and down in frequency. Well, if we swing too far, it'll go right out of our pass band. It'll go to the point where the receiver can't hear it. And whenever that happens, it makes a big spike in the audio. And when that happens, well, we have this little thing in the radio called a squelch circuit. And we probably think that the squelch works by looking for presence of carrier, but actually it looks for absence of noise. It makes use of that quieting phenomenon. And somewhere inside the radio there will be a noise detector circuit. And whenever the noise goes away, it says, aha, there's signal, and it opens up the audio and lets it come through the speaker. Well, when we get those sharp spikes from over deviation, what can happen is that looks like noise, and it makes the squelch circuit shut down. So we call that squelch clamping. If you're on simplex, you can get around it by loosening your squelch. I can do that here.
Storm. County officials commended the group's efforts and presented citations to those who had helped.
So if we open the squelch, we can get around that part of the phenomenon. But what happens if you're going through a repeater and it's the repeater's squelch that's chopping it up? Not a whole lot you can do unless you can make a real quick trip to the mountain. And even if you did, the other users probably wouldn't like to hear the noise all the time. So, yeah, if you can hear the guy reverse, you can you can do that. Of course, one might ask, if you can hear him on reverse, then why are you tying up a repeater? But oh, because he can't hear you. That often can be the case. Let's see, if you're in a spot where you can't get enough power to hit the repeater and you can't put a big enough antenna, I'd recommend using some other repeater. Or well, seems like you've eliminated most of the options. Use a different repeater. Go to HF. Yes, that's right. The repeaters have to. Right. If you just can't get enough signal to hit the repeater, you're kind of stuck. But the point we're trying to make here is there are cases where you might think that the problem is weak signal where it's really not. So sometimes somebody that's marginal will start doing the squelch clamping phenomenon, and you can tell him, back off from your mic, and you may be able to start copying him. Now, that's really counterintuitive, because you would think that less audio when you're already having a fight with signal-to-noise ratio would be the last thing you'd want. But when you start hearing the squelch close down like that, that's what you need to do. I think you're out of luck. If you can't increase power and you can't improve the antenna and it's not good enough to make the communication you want, if I understand your question right, then I think you have to be content with not communicating. Install a good telephone. That works. Anyway, some of the things that that happen with FM are a little tricky to judge by ear. And I didn't really bring the setup so I can demonstrate this very well. But you can hear someone who sounds rather soft, and yet his peaks are really going beyond the 5 kilohertz. You can also have the case where somebody just sounds phenomenally loud. You can hear the background noise, and he kind of punches holes in it when he talks, and yet he may not be over-deviating at all. And the reason is, in one case, where the guy sounds rather low, he probably does not have this mic gain control set high enough, and so he's not clipping those peaks, and the average is low, and he just sounds loud. He sounds quiet, even though his deviation is just fine. The other case, when this mic gain control is set too high, just every cycle that comes through will hit the clipper, whether it's background noise or low-level syllables or whatever, and that signal will sound very distorted. In both cases, though, the deviation may be just fine. So I think we have to be really cautious about telling people are over-deviating. It's almost impossible to tell that unless you hear the squelch clamping phenomenon. That's a pretty good indication of over-deviation. But you just about need instruments to really see what's going on the deviation side. On the other hand, setting this mic gain control is something that's best done by ear. For the guy that's talking loud and operating in a noisy environment, you want it set fairly low. For the guy that whispers from across the room in a quiet room in the basement, you need it set fairly high. And so about the only way to get it set properly for your particular situation is to set it yourself. You can send it back to the factory 2 or 3 times, and they'll set it to what they think the average person would talk at with the average microphone, but that may not have anything to do with your situation. Unfortunately, some of the newer radios don't include this control at all, and in that case, your options are more limited. You can if you need less level, that's not too hard to take care of. You can put some resistors in series or make a divider inside the radio. If you need more level, it gets harder. There's sometimes op-amp circuits that you can increase the gain by changing a resistor, or you can build an outboard preamp, or you can try and find a mic that has more output level. But a lot of the problems people have when they're not communicating well are caused by just this adjustment being set wrong. This one you don't normally touch without instruments, and rigs usually come from the factory set pretty closely for that second pot. But the first one is harder. Let's see, was there a question?
Yeah, could some of the problem be also the way people are using the microphone? Keying the mic on the seat next to you and looking out the window is really not a good idea.
Okay, yeah, really good point. I think people get various ideas on what the right distance to the microphone is, and actually there is no hard and fast answer. It depends on the microphone and the environment and how much gain the radio has. But one of the things that you can do if you have too little audio is just get closer to the microphone. And a lot of the radios are set up so that you need to be almost touching the microphone before the level comes out right. Another thing you could do is just add a whole preamp in front of the radio. This is probably easier to do with mobiles than handhelds, but QST a couple of months ago had a neat little 1 IC circuit that gave you compression and processing and a way to set the gain from the front panel. Let's see, somewhere I had some notes on what I was going to talk about tonight. I think one other thing I'd like to mention just a little bit is how much frequency spectrum does an FM signal take up? If we're swinging the carrier up 5 kilohertz and down 5 kilohertz from the center frequency, how much do you think it should take up? And before someone says 10 kilohertz, I'll tell you that's wrong. That's kind of what they thought in the early days of FM. There was a period when people believed that here was the magic answer to all the problems, because if you only deviated, say, 100 hertz, then you could put stations every 200 hertz up and down the band. Think of what that would be instead of having to put them every 20 kilohertz like we do in Utah. They tried it and it didn't work. It turns out there's this problem of sidebands. So let me just say a couple of words about sidebands. Every so often you see some discussions on the internet news groups about whether sidebands are real or whether they're mathematical fiction. Is the signal really sidebands, or is it really something else? And it's kind of like arguing over, suppose we had 6 people. We could say, is that really 6 people, or is it 5 plus 1? Or maybe it's 3 plus 3. And of course the right answer is, well, it depends on the situation. If you happen to need to take the 6 people somewhere and you have 1 sedan and 1 sports car, then you might want to look at it as 4 plus 2. If you're going to a square dance group, you might want to look at it as 3 couples. But they're all equally good ways of looking at it, and it's just a matter of picking the one that works for the situation. Well, one way that we can look at these modulated signals, when we drew this AM pattern a minute ago, we drew it as amplitude on one axis and time on the other. There's another way to look at it. There's some things that we could add together to get that same waveform. And the things that we could add together are all just single frequency tones. Let's say that we were going to send a 1,000 hertz tone on an AM station. And instead of plotting amplitude versus time, we'll plot amplitude versus frequency. And it turns out it looks something like this. We'd have a line where the carrier is. And if this is a 1,000 hertz tone we're sending, we'll have a side frequency 1,000 hertz below and another one 1,000 hertz above. And by golly, our signal takes up 2 kilohertz. And it turns out that works. You can receive a signal like that with a 2 kilohertz bandpass. And somebody listening can't tell whether you generated this by... I give up. Where's that coming from? Somebody can't tell whether you were generating that with 3 separate transmitters or whether you actually just had a carrier that you were changing the amplitude of, because if you were to draw out those 3 sine waves and just add the 3 voltages at every point in time and come up with a new one, you'd get that same pattern that we drew a minute ago. So a complicated signal like this can be represented as a bunch of single frequencies. And if you were to tune across an AM signal like this with a very narrow receiver, you would be able to see those 3 frequencies. You'd see one peak on the S meter when you passed the lower side frequency, and one when you passed the carrier, and another one when you passed the upper side frequency. And it would drop down to 0 in between. So in that sense, they're kind of real. Well, it turns out FM has sidebands too. But if we were to do this same trick, instead of just having one upper and one lower side frequency, we'd have a whole slug of them. Every 1,000 hertz, we'd have another side frequency. And some of them would be above the line, and some would be below. That kind of indicates that some of them are different phase. So the answer, theoretically, is that the FM signal takes up an infinite amount of bandwidth. These, no matter how far you go out, if you do the math, they don't ever go to 0. They do, fortunately, keep getting weaker. So eventually you get to a point where you can say, well, we'll just run it through a filter at this point and get rid of the extra ones, and it won't cause too much distortion. And to figure out just where that point is, there's something called Carson's rule that comes into play. And it's a good thing to know about. The space that an FM signal occupies is approximately the deviation plus the highest modulating frequency on either side of the carrier. The deviation plus the highest modulating frequency on either side of the carrier. And in our situation, our deviation is going to be 5 kilohertz on most of the ham bands. Our highest modulating frequency for voice, probably about 3,000 hertz. So we're going to have 8 kilohertz either side of the carrier for a total of 16. So that's about the minimum space that you can tune your radio and not clobber someone on an adjacent channel. If somebody is on 146.5.2 and you operate on 146.525, is that going to work? Nope. You're only 5 kilohertz up, so your sidebands are going to be interfering with them, and their sidebands are going to be interfering with you. Some parts of the country allocate their channels on 15 kilohertz centers, California, for example. And that's a little less than the 16 we just calculated. Probably that 1 kilohertz isn't the difference, but in order to make the receiver sound good for something that takes up 15, you probably need to make the passband at least 20 kilohertz wide for other considerations. So to make the 15 kilohertz system work, what they have to do is not allocate adjacent frequencies in the same area. If something's right in downtown LA on 146.6.1, then they won't allocate 625 until they're at least 80 miles away. It turns out our situation is such that we have a couple of big population centers and not much anywhere else in the state, so all the repeaters kind of want to be in the same place. So it's really hard to come up with allocations that meet that requirement. So it turns out we can actually get more repeaters in by going on 20 kilohertz spacing than we could if we went on 15. We weren't original in that. It was actually the state of Washington that first figured that out because they had a similar situation. But I don't know if people realize how good we have it in our rules. Most other radio services don't let you have radios where you can just plug in any old frequency you want to and start transmitting there. If they did, we'd probably have the average bulldozer operator saying, oh, I'll just run up here to this frequency, it sounds clear, and land on top of the taxi cabs or the police dispatcher. And I think when we have that privilege, we need to use it responsibly. We need to be aware of our local band plans, and we certainly need to be aware of how far away from another signal we need to be before we get out of the interference range. So generally in Utah, if there's a frequency in use, you need to be 20 kilohertz away from it before you'll avoid interfering. Let's see if I had any other wise gems that I was planning to throw in here. I think that's really it. Does anybody have any questions? Yes.
I had one comment when you're talking about microphone usage. The little electric mics that are used on the radios today. When you're holding your radio close to your mouth, don't talk directly into it because every P and F just makes a big rush of wind. The older mics, you can talk into them, they had like a filter. Like that mic you're holding right there, you can talk directly into it. People need to hold the mic sideways when they talk into it, not directly into the little tiny hole. It'll sound like
Okay, yeah, that's a good point. He's saying that with the Electret mics we have nowadays, if you talk very close and directly into the microphone, all your P's and B's and sibilants are likely to put enough of an air burst into the diaphragm that you'll make some extra noises you don't really want. And the cure for that is to talk across the mic instead of straight into it. I think if you're one of those folks that can't get the average deviation above a kilohertz, you might still be better to talk directly into it, because there's some chance we could hear you then, and any other little bit of level loss may make you totally uncopyable. But where possible, talk across the mic. That generally works better. Let's see, go ahead.
Yes, back to your previous subject on the AM, where you were showing the sidebands.
Right.
Now, of course, we've all heard a single sideband where one of those is suppressed, the other one is used.
Right.
Is there any comparable usage or theory that could be applied to FM?
Yes, you could do the very same thing with FM, but there's no particular advantage to it. It takes up more, well, depending on how much deviation you used. If you had a whole slug of side frequencies, then the FM sideband signal would still be pretty wide, and it's fairly difficult to detect. And I don't think it has any particular advantage. If you cut the deviation down to the point that there's only one sideband that's significant, then it'll work just fine, except what the signal looks like then is just exactly like AM sideband. So again, there's no particular advantage. But yeah, you could generate FM single sideband if you wanted to. Any other questions? Okay, thanks very much.
Thank you, Gordon. Oh, we have someone who forgot something. Hold on.
Tom informed me that radios are #1 in this. #2 is a porta-johns. He said if they're not up there, most likely I won't be going home that weekend. So if somebody can assist me, they're up in the Ogden area. We need to haul them down from the Ogden area up to field day and then return them back. So if somebody's up in that area, we'd appreciate it. You can get a hold of me. My number's in the microvolt.
Yeah, worst case, if someone's not going to field day but could help us out by towing them from Ogden down to this area, then someone can tow them on. That would help too. They used to have a lot in West Jordan. They no longer do. So we need to get them from Ogden. It's the portalets. I think they'll be. I think we can get them. We have them for the weekend, but I think we can get them on Thursday, and they can be towed up Thursday or Friday. The earlier the better, obviously, because people start getting up there on Thursday. So. Why? Is there some risk you're afraid of, or? Thank you. All right. Well, if anyone can help out there or help out in any other capacity, get a hold of Joel. Certainly, it's we're getting close. We were just talking earlier. We were planning a trip down there, sometime the end of May or early June to probably be before the meeting. Take a look at the site and make sure the site's okay. So, I forgot one thing before we finish here. The club station. And hey, I got an idea. Would you like to tell us what's going on with the club station? This is Alan, by the way.
We have, Tom and I and Steve and a couple of others have gone down and helped out clear out a lot of the filing cabinets down at the Red Cross. We've actually set up the stations, just put them on the tables. There's nothing really hooked up yet. We should have the letter from the attorney by the time next week, we would hope. What we're basically waiting on is making certain that if we poke a hole somewhere that we can do that. So at this point, what we plan on doing, we've got an HF station. There are at least 2 HF stations, VHF, a packet station, and it's really quite a nice place. Anybody who wants to go down, in a couple of weeks we can sure use your help, especially those who aren't afraid to climb on the outside of the building height-wise. So, any questions about that? Okay. What's that? Contact person would either be myself, which is Alan, call sign K7OPT, phone number 572-8112. The old adage, many arms make short help, so it'll be nice to have a lot of help putting some things up. Or Tom, either one of us. Any other questions about that? Good.
In 5th South, and we're planning on making, there's some residential, a lot of it's commercial, some residential things too. We're really planning on making everybody wonder where that TVI is coming from. So we're looking forward to that. Anyway, that'll be a good day when we can actually cause TVI, because that'll mean we have coax and antennas and hardline and all that good stuff. Okay, I think that's about it. Did I miss anything? Oh yeah, one minute. We got one more thing. Fred, board meeting at your place, okay? Where are you? Oh, okay. If anyone's interested with UARC board meeting next Thursday, but I will not be there. Neither will Alan. So we're going to Dayton. Who's sending code? It must be me. Okay. Oh, wait a minute. We got more in the back. Maureen. Oh, yes, I always do. Meeting after the meeting, we have 2 of them. One's at Robertino's at 53rd. Is it 53rd? What? I'm sorry. Yeah, I mean Francesco's at right, just off of Redwood, and Robertino's at 39th and Highland. Is that right? Ron. Okay. Chair, if you would, and put it on the rack. Thank you.